Good evening. In previous session, we have seen the concept of methods. In that, we have seen instance methods, class methods, and static methods. So in today's session, let us discuss about how to pass the members of one class to another class. That is, I will take two classes and just I will create an object of one class in another class, and I want to pass that object to another class. So let us see the example so that you will get a clarity on this concept. The concept is here passing members of what is meant by members is nothing but what the data and the methods that are present inside any class, passing members of one class to another class. Okay, this is our concept. So this is a small concept. Concept is what? Passing the members of one class to another class. So if I take one small class here, class A, in this I am going to take some members. I want to pass these members to another class. For example, class test. Okay, these members has to be passed to this class. So how it is going to be done? So let us take a small example to demonstrate this concept. So just I will take one class and I will take second class. I want to pass the members of first class to second class. Okay. So now I will take a class, student class I will take. Okay. Student class I am going to take. Just I want to take a constructor. Okay, here self. I want to take student roll number and his name and his marks. So that I'm going to take self dot s number, student roll number. Otherwise, I will take r number, roll number equal to same thing I'm going to pass here. So just I want to pass them also. So just I will pass roll number, name, and also I will take his marks. Okay. Right now self dot name I will take, name equal to name. After that I want to take self dot marks equal to marks. So remember one thing, here the names can be anything, but just I am taking whatever the names here I am taking, the same names I am going to take here. Otherwise you can take any other name, any other names here. Okay, let us take here roll number. Okay, there is no problem, right? So these are three instance variables I have taken here. I want to take one more method, one more instance method, display. So here we are having self. In this, what I want to do means, whatever the values I have passed to this constructor, I want to display here, or I want to print here. So print name. So name, where it is inside a self dot name. Self dot name. Okay. Next, I want to print roll number. So roll number, where it is inside ROLLNO, not RNO. Okay. So self dot roll number. Next, I want to print marks also. So marks, where it is inside is self dot marks. So these are the three fields I am going to take, three variables I am going to take in class student, and I want to print them by taking a method called as display. This is one class. Okay, now see here, I am going to take one class called as sample class. Okay, sample class I have taken here. In this, what I want to do means, just I want to modify the marks of a student. Okay, that means student marks are present here inside a inside a student class. I want to modify that student marks inside another class. Okay, for that I'm going to take define add. For example, I want to add additional marks to that particular student. So add of I want to take the student, some S I am going to take, or some STU I am going to take. So I will tell you what this STU means. Okay. Now STU dot marks equal to, I want to change it by adding some 10 marks, 10 more marks I want to add. So it is STU dot marks plus I want to add 10. Okay, right. Now I want to call display method, STU dot display, by passing. Okay, display means automatically it will call this method and it's going to execute this one. Now here the concept is, see here, just these are the two classes I have taken. Just in first class, what I have done here, I have taken 3 instance variables and I have displayed those data in display method, in instance method. Now the concept is, I am going to take one more class called as sample. In this sample class, just I want to add only 10 marks. For that I have taken one method called as add. Is it a instance method or static method? It is a static method, because here I have not taken any self. You may think that, sir, STU can also be a self. Okay, yes. Okay, so here I have taken what? STU. So we can consider it as a what? It has a static method, sorry, it has an instance method. So you have to understand the difference. In yesterday's session, I have discussed about the differences between instance and static. So instead of this self, I can also take what? Anything. So I have taken STU for example. Okay. So now observe here. For that STU, what I am passing, you can see. Right. Now see, here I am going to take one student object. Student object I have taken. So whenever I am going to take a student object, automatically student constructor is going to be executed. In that, how many parameters are there? 3 parameters are there. First one is roll number. Let us take roll number as 1 and name as Shiva, for example. So after that, marks. So the marks are only 65. Okay. The object is created. Now observe clearly. Just I will draw one small diagram for this one. So see here. Here what happens? Object is created. In this, what we are having? So these values are passed here, and here it is going to create what? Roll number equal to, I am giving what? R number. To R number, what I have passed? 1. So in roll number, what we are having? 1. After that, for name, Shiva passed. So self dot name equal to Shiva. So here what we are having? Name equal to Shiva we are going to have. After that, I'm passing what? 65 to marks. So self dot marks equal to 65. So here marks equal to how much? 65. So what is the reference for this one? S. So after executing this statement, we are going to have internally, in this way it is going to create. And also one more method we are having, that is what? Display method we are going to have. Okay, right. Now next point is, I want to add 10 marks to this 10 additional marks to the student. For that additional marks, I have to go to which class? Sample class. So that I will take additional here. Additional marks. I want to call which method? Additional marks method I want to call. So it is present in where? It is present inside a class sample. So we can consider it as a what? We can consider it as a instance method or static method. But here I want to pass one object. So see here, just I will call it as a sample dot. I want to call a method called as additional marks. Okay. In that bracket, observe carefully here. For this point, I have discussed entire concept. This point we have to understand. For these additional marks, what I am passing? I am passing E. What is this E? S. What is this S here? S is nothing but a student object. That means this entire thing is going to be passed to where? 1 minute. Okay. So this entire thing is passed to STU. That means this is pointed by whom? STU. Okay. Now STU dot marks. That means what? STU dot marks is nothing but what? 65. So STU dot marks equal to STU dot marks plus 10. That is nothing but 65 plus 10. Then it will become what? This marks become 75. Next, stu.display. Stu.display is nothing but what? This display method is going to be executed. That means the call goes from here to here. And roll number is what? Self means what now? stu. Stu is pointing to what? Same object S. So self is nothing but S now. Roll number, self dot roll number, it is nothing but 1. After that name, Shiva. After that marks, 75. Completed. Here, what is the thing we have to observe means, I am passing, this is main thing you have to understand. I am passing the members. All these are considered as what? Members. Members of one class to another class. To which class I have passed? To a class called as sample. Okay. So here this is considered as what? Sample dot additional marks. Here I can consider this one as static method also. Okay. So let us take, I will try to call it as a instance method. Just I will leave this one and I am going to use s dot. Now observe carefully. Okay, 1 minute. First I will save this and first I will call with a object. Later I will tell you why I have to call with a student. Okay, let us take a student. Student dot py. Okay, now observe. Now I'm going to execute this one. See here, student object has no attribute additional marks. So that here what happens? I have not created any object. If you want to create, sorry, this is not an object. First, let us create this one first. So let us take k as, let us take k as a sample object. Sample. For that I have to pass what? For that I have to pass one argument. Okay. So I have not passed, sorry, there is no constructor, no need of passing anything. Now I will call k dot. Now observe carefully. So here what it is saying, 1 minute, just I will clear this. Okay. So additional marks takes one positional argument, but two were given. That means here, okay, see here, sample I am going to create. In this I am having additional marks. It is having how many parameters, how many arguments? One argument. So if you are having one argument, compulsory, what should be there? If I say this one as a static method, compulsory, it is not having a at the rate static method. So compulsory we have to call with what? Sample. So here I am creating what? I have created one object of type sample. There is nothing but k. So here I am calling what? K dot additional marks. But what is the object I am passing? Inside this bracket I am passing an object. So if it is an object, someone should be, something should be there to receive here. If I am not passing this one, there is no problem. Here, if there is no concepts here, observe here. If I am not passing this one, there is no problem. It will go here and observe now. 1 minute. See here, it is giving other error. That is nothing but sample object has no attribute marks. It is going to give me some other things. That is what stu dot marks equal to plus 10 I have done here. Otherwise, if you keep here, for example, you have done in this way, for example, I will remove this one also. Now observe here. Will there be any problem? There is no problem here. Okay, because now it is acting as what? It is acting as a instance method. But what I have done in this way, I have done. So this is a static method. How I can see it as a static method means here I am passing something to this argument. Okay, that means if I pass something to this argument, compulsory it is a static method. So that no, if you want to call with a reference also you can call, but I have not placed at the rate static method, so I will not call with the help of object reference. Just I will call with a class name. So what I am passing? I am passing the members of one class, that is a student class, where all the members of student class are present inside an object. So I want to pass these values to this other class. So here what I am doing? I am going to add 10 more marks. So here SC is going to pass to STU, and in STU the marks are there. I am adding 10 marks to that marks and I am going to display the result. Now observe carefully. So it is going to give me what? Roll number 1, Shiva, and 75. Why this 75? I have given only 65 here. Okay. So it is going to add 10 more marks and it is going to display. Here one thing we have to understand is what? I am passing members of. How I am passing the members? I have placed the members first inside a S, and I am passing that S to the other class. So in that class, what I am doing? One of my member, that is nothing but marks. For that marks, I am adding 10 more marks. Okay. So and after adding that marks, I want to display all the content of that object. Okay. See here, from this class, which class? Sample class. I am accessing members of other class. Okay. How I can do it? Here I am passing the member of one class. This is member of which class? Student class. I am passing these members to the another class. Which class? Sample class. Okay. This is about the concept of passing members of one class to another class. Okay. So which members are available to which class? Student members are available to sample class. This is a small application you have to understand before going to next concepts. Now, next concept is inner class. This is very important concept. Inner classes. So what is till now we have seen about classes. Now I am asking you, I am discussing about inner classes. What is meant by inner class? Inner class means a class inside another class is called as a inner class. So you may think that, sir, what is the need of having a class inside another class? First, I will keep a heading, that is what? Inner class. Sometimes there will be a requirement to have a class inside another class. For example, I will take a small scenario, that is, for example, I will take car, or some vehicle I will take. So in this car, what are the things we are going to have? What are the parts of this car? First one I can say tires. It is having some glasses. It is having, and next it is having some toolkit, and it is having some engine. So here, for a car, we require what? Some other things, some other additional things I require. So for example, this is a car, and inside this I require what? Engine. That means inside a car, observe that inside a car I require one more thing, one more part. So this is one class. If I consider this one as one class, this is another class. If this is the requirement, if this type of application we want to develop, then I have to go to the concept of inner class. Okay, once again I'm repeating. So whenever there is a requirement of having one class in another class, then we have to go for the concept of inner classes. Okay, for example, if you are going to consider a car as one class, inside that we are having engine. I will take only engine. So this is a car. Compulsory inside a car we should have what? One more class, that is I am considering it as an engine. So in a car, is if I consider car as a class, inside that car I require compulsory engine. So without this car, will there be an engine? There will be no engine. Okay, right. Next, if you take one more example, general example, this is, if I take one university or one college, anything, it may be anything. Inside this, departments will be there. Okay, departments. So this is one class. Inside this, one more subclass is there. Sorry, inner class is there. Okay, so this is called as what? Class. This is what? Inner class. A class inside another class. So without this university, will there be a department? Not there. Right. So with this, let us go to a concept of inner classes. So one point I want to make you clear that without existing this university, will there be a concept of these departments? There is no concept of departments without university. That means without existing outer class, no chance of existing inner class. Okay, this is the point we have to understand. So compulsory, what we have to do? So inner class is always associated with what? Outer class. That means if I want to talk about department, first we have to talk about university. If I want to talk about engine, first we have to talk about car. Because why we have to talk about car? So engine will be present in many ways. So that means what? In many vehicles. For example, bus is there. Here some engine is there. Here also engine is there. If I want to talk about this one, first I have to talk about bus. If I want to talk about this engine, I have to talk about car. If I want to talk about these departments, first I have to talk about this university. Okay, right. Now the concept is, so with the classes I can't do anything. I have to talk about what? I have to talk about objects. Till now I have discussed only about the classes. Class itself cannot do anything. So for that class we have to create an object. So object can do anything. Okay, so already we know that animal, if I say an animal, for example, animal will have some properties like it will have some teeth, four legs. It can do what? Some properties. It can walk, or it can run, or it can do harm. It can do harm to the human beings. For example, I'm saying all these are properties of class called as animal. So if I take a line is having all these properties, so it is called as animal. So it will do all these things. It will run, it will walk, it will do harm to the human beings. Okay, that means what? Compulsory we have to talk about what? Objects. So we have to define the properties inside a class, and if you want to execute them or if you want to use them, I have to create an object. In the case of these inner classes also, we have to talk about objects only. So now I want to talk about the objects. So same concept, whatever we have discussed here, just I will talk in the view of an object. So how? The same statement what I have repeated before, I will repeat now. Without existing outer class, there is no inner class. I have discussed. Okay, now the concept is without existing, without, see here, without existing, without existing outer class object, without existing outer class object, there is there is no chance of existing inner class object. Inner class object, that means by this point what we have to understand? We have to understand that inner class object is always associated with outer class object. If there is no outer class object, there is no inner class object, because it is available inside that object. Okay, that is what, if this is an object, if this is existed, inner class object is existed. Okay, this you have to understand. For example, we are human beings. For example, so these are two hands. For example, I'm taking two hands and two legs. Okay, so without existing a human, if there is no concept of human being, will there be any legs or will there be any hands? There is no concept. So otherwise, this is a head, for example. Without existing human, will there be any head? There is no concept of head. Compulsory human being should be there. If human being is there, then only head will be there, hands will be there, and legs will be there. If there is no human being, there is no head, there is no hands, there is no legs. In the same way, without having the concept of outer class object, without having the concept of outer class object, there is no inner class object. This is what? Inner class object. So compulsory I can say what? This inner class object is associated with outer class object. So just I will take a small example so that you will get a small idea on this inner classes concept. Right. Now observe here, just I will take a small class. For example, I will take outer class here. So inside this, I will define a constructor. In it, I am going to take here, I will take some self. So just I want to demonstrate about this outer and inner classes. So that just I will write a print statement here. So in this print statement, I will write outer class or outer class object. Outer class object is created. Okay, outer class object is created. Right. Now next I want to talk about inner class. That means, sorry, here I have to write class. Just I have written definition, it is wrong. I have to write a class. Right. Here I want to define one more class. That means what? inside this outer class, I am writing one more class. The class name let us take as inner class. Okay, right. So here you can have any names, but better it having a starting letter as capital letter. It is recommended because inner classes, that means already whatever the classes that are present inside the Python will have capital letters. So just I will take one small example here. Attribute error is one class. So A capital, E capital. Type error is one class, T capital, E capital. So that I am also taking what with a capital letters only. Sorry. Okay, class inner. So in this class, what I want to take here also, I want to take one more constructor, underscore underscore init. In this, I want to take, observe carefully, in this I want to take what, just I want to print inner class object is created. Inner class object is created. That means first, if I want to come to inner class, first where I have to come? I have to come to outer class. Okay, next I have to go to inner class. Right. Now observe here. This is the class, and I also want to define one more method inside this inner class, that is inner method. Otherwise, just take M1. Okay. Here, this is one method of inner class. This is not the method of outer class. This is the method of inner class. And just I want to print this is inner class method. Just I want to print this statement, and I will come outside, and here I will define one more method called as M2, which is an outer class method. Here I want to take self, and just I want to print what, to say that it is a outer class method. Just I will print this is outer class method. Okay, now see this. Yes, this is a class called as outer, and here we are having what, one more inner class is there. So if I want to access anything of this outer class, anything of this outer class is nothing but what, this constructor and this M2 method and this class. This is this constructor, this class, and this M2 belongs to what, outer class, and these two belongs to what, inner class. Okay, so if I want to access anything from the outer class, I can create an object. So first I will create an object of outer class. So some x equal, otherwise o equal to some outer. So that means what happens here, outer object is going to be created. While it is going to create an outer object, it will go to this constructor, and what is there to print, outer class object is created is going to be printed. Okay, now I want to call M2. I want to call what, M2. Just I will call o dot M2. Now what happens if I call o dot M2, this method is going to be called, and this is outer class method, it will print. Now very important point, I want to call this method. I want to call this method where it is present inside a inner class, where inner class is present inside a outer class. If I want to access any members of outer class, that means what, any members means what, these three are the members of outer class. Okay, outer class. So if I want to access these members, how I have access this M2? How I have accessed this M2? By using an object of O. In the same way, if I want to access the members of inner class, that is M1. So if I want to access M1, which object has to be created? Inner object. Where is this inner present? Inside the outer class. So to access the outer class members, I have to use O. That is what, object. Okay. For that, I am writing I equal to inner class O dot inner, because it is present where, inside outer class object, sorry, inside outer class. For to represent an outer class, I am going to write O dot. So O dot inner. Now observe here, whenever I am going to it in this way, inner class constructor is going to be called, and inner class object is created, will be printed. Just I want to call this M1. Just call by using I dot M1. So now you can observe that for to access the members of outer class, I have to use outer object. So to access the members of inner class, I have to use what, I dot M1. What is this I? It is nothing but inner class object. How we can say it is a inner class object? So O dot inner, that means it is pointing to this inner class. This indicates what? Inner class object. Okay. So I dot M1. So I is what? Inner class object. It is pointing to inner class object, and it can call what? It can call M1. Now observe the output of this program. We got what? Outer class object is created. So whenever I am going to execute this statement, internally this constructor is going to be called and outer class object is created, is printed. Next, after that, what I called O2 dot M2. That means it will go to O. O is belonging to what? Outer class object. So it will go to outer class and it will check for M2. It is present. So it is going to print what? This is outer class method. So this is outer class method is printed. After that, I am going to create which class? So which object? Inner class object. How to create inner class object? O dot inner. Why I have to write O dot inner? Because to access anything from an outer class, I have to use an object called as O. So inner class is also member of outer class. So O dot inner. O dot inner indicates this class. Okay, O dot inner indicates this class. So I want to create the object of this class. So just I will create open bracket and close bracket here, and I want to point that object. I want to refer that object by using a I. So I is referring to a object which is nothing but what? Inner class object. So I dot M1. So is there any M1 inside a inner class? Yes, it is there. So it will be executed. So this is inner class method is going to be executed finally. When this is going to be executed? When an inner class object is created. That means here inner class object is created. At that time, this constructor is going to be executed. Okay. This is a small demonstration about your inner class. So now you may get the doubt that, sir, is it the only way to create a inner class object? No, we are having one more way or two more ways we are going to have. Just I will write one first way. This is first way. Second way I am going to write. That way is, instead of writing that one, I can write outer object here. This is what? Outer object. Outer open bracket close bracket indicates what? Object only. So outer object dot inner object. So if I write O also, there is no problem. Otherwise, I can write in this way also. So now see, observe here, you will get the same output. There is no problem. But here one more statement that is executed. Reason is, see here, observe this one carefully. Outer class, this is no problem. Here outer class object is created because here I am going to create one more object, outer object. So when I'm writing this statement, this is going to be called. This is going to be called. So no need of this one. Let us consider, I don't require this one. I am talking only about inner class. Now what happens? To create a inner class, first I require outer. So that I have written outer object. So if I am going to create outer object, automatically outer constructor is going to be executed. That is, outer class object is created, will be printed. After that, inner class object is created, so that this constructor is going to be executed. That is, inner class object is created. After that, I am calling what? I dot M1. So it is going to call this M1 method. That is what? This is inner class method is going to be executed. So observe this one. Okay. This is about inner class object creation. One more thing is there that I will so same thing here. Okay, these are the two ways. So to call this one, I can also call how? Outer dot without creating object. Without creating object also I can call M1. So I will not create this one, but also I can call M1. So observe this one. Same output. Okay. Instead of creating a reference, without reference I have created this inner class object and I have called M1. Okay. So these are the ways to create inner class object, and to access inner class object we can access in these three ways. Now just I will take one more small example so that you will get a clarity on this one. Just I want to fill a small application. Okay. Student application. So just I will take class student. Okay. Class student is going to have what? His name will be there, and he is having his roll number, name, roll number, and date of birth I will take. So I will take them as the instance variables. So init, I will take self here, and now I want to take what? Self dot roll number I want to take. R number equal to R number I am going to take. Otherwise directly I will take roll number is 10 I will take. Next self dot name. I will take name as Shiva. Okay. Next, after that, I want to take date of birth. Just I will take a date of birth of the student. Self dot date of birth. So observe now here. In date of birth, we can have what? We can have three fields. One is date, another one is date. After that, month will be there. After that, year will be there. So three things are there separately. So that I will go to one more class. So I will not write this one now. Just I will go to one more class. That is what? Class. Date of birth I want to write. So just I will write DOB. Class name is DOB. Otherwise, I will write full name. Date of birth. Class name is what? Date of birth. This is the class name. Inside this, what are the fields we are going to have? Self dot day or date I will write. Self dot date equal to, here what I want to write, I can write any date. Let us take 27. Okay. Self dot month. Okay. Self dot month equal to 6 I will take. Self dot after that year. Self dot year equal to 1989. So these are the fields we are having in class date of birth. So to display these things, just I will write one more. Sorry, these things has to be written inside what? Inside a constructor. Okay. Underscore underscore init underscore underscore. Here I am going to write self. So these are what? Members of this init. There is no constructor. Now observe here. I want to display the date of birth here. So for that I am going to write what? Display method I am going to take. I will write here self. So to display this, what I have to write? Just I want to print. So print of I want to print date of birth. Just I will take date. Here I will take this one. Otherwise, just I will take entire thing. Okay, that is what date in the form of self dot date I will take. After date, I want to keep a hyphen. Okay, just I will keep hyphen here. Hyphen. Next, I want to take month. Self dot month I am going to take. Okay. After that, I want to keep one more hyphen. So for that, I am going to take hyphen here. Next, lastly, I am going to take self dot year. Self dot year. Now here what happens? It is going to display date of birth. Right. So before this, I want to keep to say that it is a date of birth. Just I will keep DOB here. Capital letters DOB. It is nothing but date of birth. So this is about date of birth. Now I require this date of birth here. So if I require all these fields here, what I have to write? Just I have to create I have to call a method called as what? Display method I have to call. Okay. So who has to, where it is present? See, observe carefully. This is very important point. So it is present inside a student object only, inside a student class only. So if I write, so to access this date of birth, can I access by using the self? Yes, I can access. So self dot, inside the self is nothing but what? This class. So self dot DOB. DOB is nothing but what? Sorry, this is what? Date of birth. Self dot date of birth. Date of birth. That means what I have created here. So here I have created an object of type date of birth. Okay, that is going to be stored in what? DOB. Okay, observe this one carefully. Okay, now just I will create an object of student here. Just I will create student object S. Okay, student object I have created here. Next, I want to display S dot display. Right now, see S dot display. After that, I want date of birth. Okay, I want date of birth. So 1 minute. Okay, anyway, I have not displayed these details of student, that is roll number and name. For that, I am defining here. So this display is different. So two displays are there. One is what? Inner class display. Another one is outer class display. So here I want to display roll number and name. So just I will display. Here I will write roll number. Roll number I will write here. And roll number is present where? In self dot r number. Roll number is present here. Okay. After that, I want to take what? Student name. Otherwise, just I will write name. Name where it is in self dot name. Okay, completed. So first I want to display this one. Okay, after that I want to display date of birth also. So to display date of birth, it is present where? Inside a class called as date of birth. So now what is printed with the help of this s dot display? This roll number is printed and also name is printed here. Now I want to talk about this display. So already here we are having what? In S we are having this one. So I am going to write what? So it is what? Date of birth. So I am going to write object name as D. Here s dot I want to call what? I want to call in S what we are having date of birth. That is what? DOB I want to call. DOB. Okay, if I write this one, just I will call after this D dot display. Observe carefully. Just I will execute this one. Later I will tell you clearly. So name S is not defined. 1 minute. S dot display. Sorry, here I have written capital S. Sorry. Right now observe here. So we got date of birth. Object has no attribute data. Oh, I think I have written data. It is date. Somewhere I have written data. So that is here. Okay. Now observe. So see here, roll number and name is printed, and I have printed the date of birth also. Now just I will explain here clearly what happened in this program. See here, first come here. Student object is created. Inside student object, what will be there? So whenever this object is created, it will go here and it is going to create what? R number equal to 10. And after that, name equal to Shiva. Name equal to Shiva. And here what happens is going to create one more object. One more object. Which object? It is date of birth object. So it is creating date of birth object. So that means what? When it is going to be created, it will go to here. And here what is there? Date is there, that is 27. And next month is there, it is 6. And year is there, it is 1989. In this way, it is going to create. And observe carefully. In inside inner object, we are having display method. Inner object display method is there. And outer also we are having display. Okay, 1 minute. Clearly, I will write this one so that you will get clarity on this. See, this is a large one I'm taking. This is what? Student object. While creating this object, control comes here. It is going to have what? Roll number equal to 10 and next name equal to Shiva we are having. After that, here for date of birth, what we are having? For date of birth, we are having one more object. Which object? It is date of birth class object. So here what happens? Date of birth object is going to be created. When this object is going to be created, it will go to its constructor. Which constructor? Date of birth class constructor. So it will come here, and inside this we are having three variables. That is what? Date. Just I am writing D for date. 27. Month, here what happens? 6. And next year we are having 1989. After that, in this class I am having display method also. Here one display will be created, and this is completed. After that, here we are having one more display in outer class. So for that, it is going to be created. Okay. So in this way, internally the memory is going to be created. Okay. So this is first step. This is first step only. Next, s dot display is for this s play. Sorry, for this s is there in display s. So the it will go to this display and it is going to print what? Roll number, and it will print what? So see here, from here I am calling, so that it will call here. So who is calling? S is calling. So self will become what? S. So s dot roll number, what is that? 10 it is going to print. Next, s dot name, it is going to print Shiva. Completed. Next, observe here, s dot dob. In S, observe this. In S, is there any dob? Yes, dob is there. So I am placing it in what? D. That means this entire thing is pointing by what now? D. This entire thing is pointing by D. So D dot display, is there anything to display in D? Yes, there is. So it will go to here. On calling this display, sorry, who is calling this display? D. That is nothing but D is self is nothing but D now. D dot date. D dot not date is nothing but 27. Here 27 will be printed. Hyphen will be printed. D dot month 6. D dot year is nothing but 1989. So in this way it is going to execute. So if you are having these type of applications, we have to go for the concept of inner classes. Okay. Next, let us take one more example. Okay. Okay, it's enough. Okay, because already I have given a small outer and inner concept, and also I have taken one real-time example here where student details contains some other data of birth. Otherwise, if we consider any other applications where one more requirement, for example, see here, just I will take one class here, one object, otherwise one object I have taken, it requires some data here. Inside this one more object is required where it contains some other data. Inside this one more object is required, I can take any number of classes here. Okay, no problem. Otherwise, if in one object only or in one class only, if you want to take n number of inner classes, it is possible, there is no problem. So in single class, let us say this is S class. So here this is one inner class, this is second inner class, this is third inner class. There is no problem. Okay. In one class, we can have any number of inner classes. Okay. Right. Now let us go to next concept. That is the concept of garbage collection. Very important concept. Garbage collection or garbage collector, I can say. So first I will tell you what is meant by this garbage collector and what is the need of this garbage collector. So before this, I will take a real time, one small example. That is, today I was very hungry at 6 o'clock. Let us take, I was very hungry at 6 o'clock. So that while coming from office, while from one person, one employee is coming from office to home. In between, he bought one, what we can say, lace packet, lace. He bought from lace to his home, and as he was very hungry, he has completed this lace. When he was bringing it, he will bring it carefully here to the home, and he will place in a table. After that, he will open it and he will eat it. After that, what happens? What happens? He is going to throw it. He will leave it as it is. Okay, he will not care about that cover. He is not going to care about that waste until it is in usage. Our this particular person is going to take care of this lace packet. Once it is completed, he is not caring about that lace packet. Okay, that means why he is not caring about that lace packet? Because it is waste now, because it is completed. Okay, now I will come to real case now. So here, if you take anything, I will take the real scenario only. That is, one object is created. That means whenever you are going to create an object, some memory is going to be created. Let us consider object O. So this object is linked with a files. For example, this is a file here. So this object is linked with a file in a program. This is a program. Okay. Now, if anything want to be accessed from this file, this O is responsible. Now see, my task is completed here. My task is completed, so that I'm going to remove this connection by using the close concept. Okay. F close I am going to use, so that this connection is going to be removed. So is there any use of this object now? Not there. That means what? This is not pointing to anyone. I want to remove this reference also. I want to remove this reference. And now, is it what? Is it accessing by anyone or is it referring by anyone? No. So is it necessary now? It is not necessary for our program. The memory can be deleted and this memory can be allocated to any other person. Okay, any other object. So don't worry. Once again, I will repeat the same scenario here also. So now see, this is an object for A value. So now what is the A value here? 10. Let us consider 200, 280 I will take. A value is 280. A equal to 280 I have written here. So that internally one location is going to be created and it is pointing by A. When here I am going to A equal to 375. Now observe carefully. So now 375 will be created and this A will be pointed to here. Here this will be removed. This link will be removed to this object. Now, is this memory location is used by any other references or not? It is not used by any references. But what is the need of having this one in my memory? Is it necessary in my memory now? No. So just what we have to do, we have to delete it. Who will delete it? Concept is this one. Who is creating it? Program is creating. Who has to delete it? Generally, program has to delete it. But we are not deleting it. In the concept of C or C++, I will take, because in C we are not having the concept of objects. So I'm taking C++ example. Here we are having the concept of, that means what, user is going to allocate memory and user is going to what we can say, is going to delete that object or destroy that object. Okay, in the same way, in our Python also we are creating the objects, but we are not going to delete the objects. We are not going to delete the objects. Then who is going, it is not compulsory to delete the objects. Then you may think that, sir, if I'm going to create A equal to 375, I have created. Next I'm going to create 480, I'm going to create. Now what happens? This is referring for this one and it is going to be removed here. This reference is going to be removed. Now one more thing. Now this reference is removed and A is pointed to this one. Then what if I am doing this one for 100 times? If I do or 1000 times, for example, without deleting all these objects, I am going to change the reference, change the A pointing to another objects. That means what? First A is pointing to 280, next 375, next something, next something. So all these objects are what? For all these objects, some memory has to be allocated. Okay. If I am not going to remove them, what happens? This memory is wasted. Unnecessarily, it is going to be stored in my memory only. Okay, without usage. So we have to delete. Okay. So every time how we can delete, it's very difficult for the user. Okay, for example, it is difficult for the user, so that no need of taking care about these all destroying things. Okay, because for our Python and also in Java also we are having the concept of garbage collector. Now same, I will take the lace example here. So I will not care about the lace here. The person who is eating, he will not care. Then who will care about that empty packet? One garbage collector, which is nothing but maid, I can say. Maid means what? Worker. Okay, who is going to sweep my home? So he is going to take care. That means what? He is going to remove or she is going to remove the empty cover, which is nothing but a waste. I can consider it as a waste now. So because it is not going to be used by anyone, so I will take this cover and I will throw it. In the same way, here you are going to create object, and if no reference is pointing to that particular object, then what we can do? Then there it is not compulsory to delete by a programmer. Internally, we are having one concept called as garbage collector. That garbage collector is going to take care that it is going to remove the objects which is not pointing by any references, otherwise which is not referred by anyone. That objects are going to be freed or deleted by whom? By garbage collector. Okay. Now in C++ we are having the concept of user has to delete it, but in our Python we can leave it automatically, or garbage collector is going to remove it. So when garbage collector is going to remove it, if no reference is pointing to that, means if no one are referring to that object, then only your garbage collector is going to remove those type of objects. Okay, right. So the main object of this garbage collector is what? To destroy these objects which are useless. When we can say an object as useless, if it is not pointing by, if it is not referring by any references, then I can say that object as a useless. Okay. Now see, just I will take a real-time example so that you will get clarity on that one. That means I will take a small application. So now see here, just I will take A equal to 123. Otherwise I will take, okay, 123 I will take, sorry. Okay, 563 I have taken. If I print A, see 563 is printed. ID of A I am going to print. See, address is what? 203.047.68 is there. Now I'm changing the value of A, that is 986 I have taken. Now print ID of A. Is it same or not? It is not same, because this is first it is pointing 563 object, next it is pointing what, 986 object. Okay. Now what happens for this object? This what is the object that is present in this address? What happened for it? It is removed by garbage collector. So to check that whether garbage collector is available or not, that means whether it is enabled or not, whether it is disabled or not, how we have to check? We are having the concept, we are having some methods to enable, to disable the garbage collector also. So now you may think that, sir, if you are disabling that, who is going to take care of that useless objects? No one will take, because we are disabling it. So by default it is in enable state only. It is in which state? Enable state only. To check that, just use one thing here. Just I will take here gc dot is enable. The method name is what? Is enable method. So here it is telling us what? So gc is not defined. Okay, I will define that. 1 minute. Just I will write a small program for that, because gc is present in gc is a package. Sorry, it is a module. So what I would write, gc dot is enable. Is enabled. Is enabled I have written. Is enabled. So it is saying what? True. Because by default, every time garbage collector is what? In enable state only. So that whenever some object is going to be freed, whenever one object is going to be not referred by any other references, then automatically it has to be removed. So the garbage collector is always ready to take that. Okay, the task of garbage collector is what? To remove the waste. Waste means what? Useless objects. Okay. Now observe the case here. Now I will tell you two more methods. So we are having mainly three methods. First one is enable. Enable is a method to enable the garbage collector. Next, disable, to disable the garbage collector. Next, to check whether the garbage collector is enabled or disabled, I am having one more method called as is enabled. Is, just now we have seen this one. Okay, is enabled. These three methods, to demonstrate these three methods, I will give you a small application, just a small program I will write here. So where this enabled, disabled and is enabled is present inside a module called as gc, so that I have to import that. So I have imported that. Now just I want to do what? Just I want to print whether initially garbage collector is enabled or not. So is enabled. So I'm checking whether garbage collector is enabled or not. By default it is going to have what? By default it is enabled. Next, after that, so first I will execute this one. Okay, so now what it is telling? True. Next, I want to disable that one now. gc dot disable. Now I have disabled that. Now I will check whether gc is enabled or disabled now. So now see, first it will tell what? True. After that it is saying what? False. Reason is what? I am disabled it. Whenever it is asking is enabled, what I can say, what it is telling, it is disabled, so that it is going to give you what? False. Again I want to enable it. So enabled now. Now check once. Okay. Now observe here. True, false, true. True means what? Initially by default it is what? It is enabled. After that I am making it as a disabled. After that again I am making it as a enable. So if you want to make garbage collector enable or disable, we are having the methods. We are having the methods in our garbage collector. Sorry, GC module. Okay, right. Now before going to, okay, this is about garbage collector. You have to remember about these points. So before going to delete, observe carefully. Before going to delete, an object, so what are the things we have to see? First thing, this is an object I want to remove. So it is pointing by A, it is pointing by B, it is pointing by C. Now observe carefully. So the value is 259 here. So I am making A value as 536. Now what happens? A will not point to this object, it will point to this one. And this reference is going to be removed. Now observe carefully. Now will this object is going to be removed? According to our previous scenario, it has to be removed. But it is pointing by some other references. So it will not be removed by garbage collector. So if the object is not referred by any of the references, then that object has to be removed by the garbage collector. But here, 3 references are there for this object. So what should be happen? If I am removing one reference to this object, 2 more are there. So this object should not be removed by the garbage collector. This is a very important point. Okay. Now, so to check these type of concepts, we are going for a concept called as destructors. So constructor means what? Constructing. Destructor means what? It is going to destroy. Okay. While destroying anything, we have to check something whether we have to destroy or not. Okay. So for constructing, we are having with some special method called as underscore init underscore we are having. In the same way, for our destruction purpose, destructor also we are having a special method called as underscore del. Okay, this is one method which is used for the concept of destruction. Okay, so when this is going to be used, so just before removing or destroying an object, who is going to destroying an object? Garbage collector is going to destroy an object. So before going to destroy an object, any object, garbage collector has to call this destructor. Okay, garbage collector has to call what? This destructor. To what? To check whether there is any other references are pointing to that particular object or not. So all these things are going to be verified by this destructor, and if no one are going to refer this object, that object has to be removed. That means what we can say, this destructor is going to have cleanup activity. So already we have discussed about finally in our exception handling. So why we are going to write finally? So to close a cleanup code, we are going to write in that finally. In the same way, or resource deallocation we have written there finally. In the same way here also, before going to delete an object, we have to check whether anything is there which is related to that object, whether that object is pointing by any other references or not. It will check all those activities, and if it is not pointing by any of the references, then only destructor has to or garbage collector has to remove that. To check about this concept, that code will be written inside this destructor. So once destructor execution is completed, that means what? If it is completed successfully, the meaning of that one is what? No one are pointing to that particular object. So if this destructor is completed successfully, then garbage collector is going to destroy that object. Okay, right. This is about the concept of destructor. Once again, I will repeat that. So destructor is for what? Destructor is for destructing an object. So for constructing, I have used what? I have used the concept of underscore init method. For destroying, I'm going to use a special method called as underscore del. So what is meant by destruction? Already we know what is the use of a garbage collector. So it's going to destroy an object or delete an object. So before going to delete an object, so a destructor will be executed. What that destructor is going to contain? Destructor is going to contain a cleanup code. What is meant by cleanup code means? Here if I take one object, there is only one reference. I am removing this reference. Then what happens? This object is eligible for garbage collector. That means this object can be removed by the garbage collector now. Okay, how we can say it is not referred by anything? So whether it is going to refer by any of the references or not, okay, uh, that will be checked inside where? Inside a destructor. Cleanup code will be there inside this destructor. Now it can be deal after this one, it is going to check, so no one are there. So the execution of this destructor is completed automatically. If the destructor is completed, garbage collector can remove this one. Okay, next let us consider B is pointing and A is pointing. A reference is removed. Now B is pointing. Can I delete this object? No, it cannot be deleted. Reason is it is pointing by some other object, so that the destructor will not complete its work. It will wait until this reference is removed. So after this destructor is completed, then only garbage collector will remove this object. So until someone is pointing to that object, destructor will not be completed. Okay, once the destructor is going to be completed, means the meaning of that one is no one is referring to that object, so that your garbage collector can remove that object. So this is the concept of destructor. So just I will take a small example to demonstrate about this destructor concept. Now see, here I will take a class test or class anything. Here I will take one constructor. When constructor is going to be called, when an object is created. When destructor is going to be called, when object is going to be removed or deleted. Okay, object created. For example, I'm going to write object created. Next, after this, I want to write a destructor. Same, def underscore underscore delete. When this destructor is going to be called, once the object is going to be destroyed before going to be deleted, it is going to be called. Before going to be created, constructor is going to be called. Before going to be destroyed, destructor is going to be called. Destructor called. Okay, destructor called. So now observe here. Just I will go outside of this class. I will create an object t equal to test. I am going to write the class name is test, so that I have created one object. Whenever this object is created, automatically this constructor is going to be called, and what is there in that object created will be printed. After that, now see, I am going to do what here. I don't want to one object is created. I am going to make it as a none. That means until now t is pointing to test object. I am telling what t don't point to anyone. That means you have to point to none. None means what? This object is not pointing to anyone now. Just I will write here. First, what happens when object is created? Test object is created and it is pointing by t. Now what I am making t equal to none. That means it is not pointing to anyone. It is pointing to none. So it is not pointing to this one. Now, is this object is pointing by anyone or referring by anyone? No one. So this object can be removed or not? Yes. So before going to this removing this object, which one has to be executed? This destructor has to be executed. So now what happens? It will call this destructor. After that, what happens? After calling that destructor, it will print destructor called. After this destructor is completed, what happens? This object will be removed internally. After that, I will write what? Print of end application or completed. Just I will write here completed. So you can observe clearly now. So what happens? First object created. That means whenever I am going to create an object, constructor is called, object creator is printed. Now I am making what? T equal to none. That means this object is not referred by anyone. So that means what? This object is eligible for garbage collector. That means garbage collector can remove this object now. So before going to remove this object, we have to call what? Destructor. So destructor called is printed here. After that, completed is going to be printed. So this is the concept of destructor. So what is the point here? We have to remember, if the object does not contain any references, then only our garbage collector is going to remove that particular object. Okay, that means what? Here let us take, this is pointing by t. After that, it is pointing by t1. It is pointing by t2. Now tell me, I am making t as none. Can this object can be removed or not? No. If I'm removing this one, can this object can be removed or destroyed? No, because it is pointing. If I remove this one also, can this object can be removed or not? Yes. That means if the count of these references is 0, that means if no one is referring this object, then only we can delete that object. Not we can, garbage collector can delete that object. That means what? If the reference count is 0, then only object is going to be eligible for garbage collector, or garbage collector can remove this object. So for that I will take a small example. Now observe carefully here. Just I will take, otherwise just I will take a same program, but here I will create more objects here. T1 is one object. After that I am making T2 equal to T1, T2 equal to T1. After that I am going to write T3 equal to T2 I am going to write. And now I want to delete T1. Already you know what is the use of delete. After that, just I want to see how many, whether object is deleted or not. Okay. So if object is deleted, remember that whenever object is deleted, this constructor has to be called. Once the object is deleted, constructor has to be called. Now, before going to delete the object, constructor has to be called. But now whether the constructor is called or not, I will check. Now, next one. Just I will print, for that I will print a statements here. Not yet destroyed, not yet destroyed. After that I will delete T2 also. Okay, here also same statement I will tell you. Here also I will tell same statement, not yet destroyed. After that what happened means I will delete T3 also. Now what happened here? Destroyed. Now it will print what? Destroyed. And after that it is going to tell completed. Otherwise I will write this statement last. Okay, just I will write here. I will write here. Before that I will write what? Not yet destroyed I have written. And after that I will delete what? I will write delete T3. Now what happened? I will delete this one also. Just I will delete T3 because here destructor called. After destructor called, what happens? Automatically it is going to be deleted or destroyed. Destroyed. Now observe carefully what I have done here means. Here I am going to take, I am going to create one object, that is T1. This is T1 object or test object which is pointing by, which is referring by T1. I am telling what T2 equal to T1. That means now T2 is also pointing to T1. Next I am telling what T3 equal to T2. That means T3 is also pointing to this one. Now I am telling what delete T1. So it is pointing to this object. So I am going to delete this one. I cannot delete this one because it is pointing by two more things. So it will print what? Not yet destroyed. Next, delete T2. I am deleting this T2 also. I cannot remove this object. Reason is what? T3 is pointing to this one. Next, after that, not yet destroyed will be printed. T3, delete T3. If I delete T3, is this object is going to point by anyone? No one. So that automatically what happens? Destructor is going to be called and destructor called will be printed. After that, destroyed is going to be printed. Okay. Now just I will execute this program. Now see. So what happens? Object created is, because while creating this object, constructor is going to be called. After that, not yet destroyed. So I am deleting T1 at that time, not yet destroyed. I am deleting T2, not yet destroyed. I am deleting T3. What happens? Whenever I am going to delete T3, that object is free. It is not referring by anyone. Now automatically constructor is going to be called. So that which one is going to printed? Destructor called is going to be printed. Finally, what happens? Destroyed is going to be printed. Okay. This is a small example you have to understand about the concept of destructors. Okay, now how many times a destructor will be called for an object? Only once a destructor will be called by any object. When it is going to be deleted, at that time only, at that time only it is going to be called. Whenever a destructor is called, when it is going to be called? Whenever an object is going to be destroyed, it is going to be called. So remember one point: creation will be once, destruction will be once. So see, when I am creating, constructor is going to be called. When I am destroying, destructor will be called. So object can be created once, object can be destroyed once, so that constructor will be called once, destructor will be called once on an object, otherwise on every object. For every object, constructor will be called only once and destructor will be called only once. This is the point we have to understand. Next, so already I told you what, if our count is having, if our reference count is 0, then only our object is going to be destroyed. Now I want to check the count. How many values are there? How many references are there for my object? So for that, I am going for a module called as sys module. In this, I am having a method called as get reference count. Observe here, just I am going to write print of sys dot get ref count, reference count of, I want to write T1. Observe that I want to write what? T1. I want to write T1, so that it is going to tell you what reference count it is going to give you. After this, I am going to delete one. After deleting also, I am printing the same thing. After deleting 2 also, I am printing same thing. After this one, observe here what happens. So see, object created, it is going to tell what? 4 here. It is going to tell what? Reference count is 4. 1 minute. So just I will take a T1 count here. After T1 is removed, what will be there? Will T1 will be there? Not there. So I will take T2 here. I will take T3 here. Okay, after removing T3 also nothing will be there here. So no need of taking here. Now observe here what happens. 4, 3, 2. Okay. Okay. For every object, Python internally maintains one default reference, so that we are going to get what here? One more count is going to be. You may get some doubt that, sir, who is going to refer that? Self is there. Okay. You have to understand that one. Self is by default, it's going to refer what? An object. So here, how many? See, just I will draw a diagram. So see, first it is pointing by what? T1. Now here T2 is pointing and T3 is pointing. By default, who is pointing? Self is pointing. So that if I ask here, how many are there? 4 are there. So answer is 4. I have deleted T1, so it is removed. So now if I am asking about T2, so how many are there? 1, 2, 3 are there. Here it will print 3. Now see, here T3, so it is removed now. Sorry, here it is removed. After that, I am asking count. How many are there? 2 are there. So it will print 2. After that, D3 is removed. If I print here, what can I print here? Delete of, after deleting T3, I cannot call it as a self. I cannot call what can I say? Get reference count of self I cannot call. So what can I call? I cannot call this get reference count on any reference, because all references are removed. So I cannot call here. So that so we get answer as what? 4, 3, 2. Observe that what we got? 4, 3, 2. Okay. So this is the concept of garbage collector and destructors. So how to count? Sorry, how to get the count of the references by using a method called as get ref count. It is present in sys module. So one more point we have to understand, very important. We have to remember about this references is what? For every object internally, one default reference is there. Default reference variable is there. That is self. So don't confuse here, because here we got 4. Reason is what? Self is 1. We have only T1, T2, T3, but self is also 1. So that we are going to get output as what? 4 here. So once again, I'm repeating, for every object internally, we are having what? One default variable is pointing to that. One reference variable is pointing to that. That is self. Okay. So with this, we have completed the concept of what? Garbage collector and destructors. So in next session, we are going to see about an important concept, that is polymorphism. Okay. Thank you.